Okay, so it's 7:05, so I guess I'll get going. So we're going to start with some review questions from back in chapter 2. So, all right, so the first question should be pretty simple. How many seconds does it take for the second hand of a clock to rotate through an angle that measures 72 degrees? So I'll give like 2 minutes for this one. Should be pretty simple. Okay, so for this question, so you think like the rotating around a clock, it would take 360 degrees, and there's 60 seconds on the clock. So if you think you do 360 divided by 60, you'll have 6 degrees per second. So if you use that rate, 72 degrees divided by 6 degrees per second, and you'll have you should get 12 seconds. Yeah. Okay, so now for the next one. Okay, knowing that AB is parallel to CD, find CGE, HGC, FHB, and BHG. Give you 1 minute. Okay, so for this question, first, if you want CGE, if you look, it's just vertical angles to this one angle, DGF, that you know. So this angle is going to be congruent to this one. So this one's going to be, so CGE is going to be 58 degrees. And if you look, HGC is supplementary to DGF. So it's going to be equal to 180 minus 58. So this is going to be 122 for this angle. And then FHB is right here. If you look, if these two line segments are parallel and you have FE as the transversal, then these two angles are going to correspond. So FHB is also going to equal 58 degrees. And then for BHG, it's the same thing. It's going to be supplementary with FHB. So it's also just going to be 180 minus 58, so 122. Okay, so here to just find what X is, I'll give maybe a minute. This should be a quick one. Okay, so for this question, you see ABC and BCD are going to correspond to each other. So these two are going to be equal. And since you can kind of form like a parallelogram BEDC with 3x, 5x, 3x, 5x. So you could add all them up and you would get 16x equals 360. And then if you do that, if you just divide both sides by 16, you get x equals 22.5. Okay, so for this one, here it is. You just have to find what x is. And this will take, I'll give maybe 3 minutes for this one. Okay, so would someone like to explain this one? This like their proof and why is like I see they're saying 110. Would someone like to explain why does it equal 110?
Why does yes.
Okay, go ahead.
So like my teacher calls this a bullet model for some reason. My other geometry teacher, they call it a bullet model because it looks like a bullet. So the ABGED, they call it a bullet model, and they say that angle B plus BGE plus DEG equals 360 degrees. And here, BGE is 140. So ABG is 360 degrees minus 110 minus 140.
Which is 110.
Yeah, that is correct. But there is also another way to do it. So if you like, here, would you like to explain it?
The way I solved it is all you needed to do is just find out BGE equals 140 degrees, and how you prove that is that because line BG and line FE intersect. So the angles added up equals 360 degrees. So 140 so BG equals 140 degrees. Then I just subtracted 140 degrees and 110 from 360, and boom, you get 110.
Okay, so that's like similar to what Alvin did. Okay, but a different way to do it is you could draw a parallel line from G to say like the point H here, and it's gonna be parallel to A, B, and DE. So now you have like E and F as a transversal. So if you imagine this line here, you're going to have 110. Or you're going to cut this angle and it's going to equal 70. And if you like, since this is similar to like a parallelogram structure, and the way a parallelogram is that like the two angles that aren't equal to each other will add up to 180. So if you have this angle, which is 140 cut in half, and which is 70, and then you have x of 180 minus 70, which is 110. Okay. Now, for this question, find x. Give 2 minutes. Okay, so again, would someone like to explain this one?
So how I did it is x plus 10 plus x plus 4x minus 10 equals 180 degrees. How you do that, how you make that conclusion is you can just slide angle AEF up to align with angle line DA, and you see that it creates a straight line. So then you can say that x equals 180 degrees. The two 10s, plus 10 and minus 10, they cancel each other out. So that just leaves us with 6x equals 180 degrees. So x equals 30.
Okay, yeah, that's correct. I think there's maybe like some better terminology you could have used. Like if you extended out AB as a parallel line, then you would have the corresponding angle to be equal to 4x minus 10 instead of just saying you slid up the angle. But that's the correct way to solve it, where these two angles are supplementary. This is a weird question. I'll skip this one. Okay, I think you already know this, but yeah, angle XY are the remote interior angles, and basically the exterior angles, so in this case, XZP is going to be equal to angle X plus angle Y. All right. So if triangle ABC has an interior angles in the ratio of 3, 4, and 5, what is the measure of its smallest exterior angle? You have maybe 2 to 3 minutes. Okay, so would anyone like to take a stab at this question, or do you want me to go ahead with the explanation?
So how we can find the smallest angle is 3 over 4, 3 over 3 plus 4 plus 5, which is 3 over 12, plus 100, divided by 108 times 180 equals the smallest angle. So that's 45 degrees. That's 45 degrees. So the other two angles in terms of x is x plus 15 and x plus 30. So the medium angle the medium angle is 60 and the largest angle is 75.
Okay, but the question was asking the measure of the smallest exterior angle, not the interior angles. So so basically, first the way you would start it is set up since the ratios are 3 to 4 to 5, you can set it up as 3x for angle A, 4x for angle B, and 5x for angle C. And if you add them all up, so it'd be 12x, which is going to equal 180, which is the sum of the interior angles. So you're going to have 12x equals 180. So x should equal 15. So then you'll have, and then if you remember from the remote interior angle, or whatever it was called, remote interior angles, that the exterior angles are equal to the other two angles. So you're going to have one exterior angle that's 3x plus 4x. You're going to have another that's 3x plus 5x. And then the largest one's going to be 4x plus 5x. So you're going to have one exterior angle equals 7x. The other is going to equal 8x. And the largest is going to equal 9x. So if you're looking for the smallest exterior angle, that's going to be the 7x, which is 7 times 15, which is just 105 degrees. Okay, this is just like a quick logic question. Is it possible for two exterior angles of one triangle to be supplementary angles? I think would someone just like to try this right off the bat? A little bit of time, like it's just a quick logic.
No. No.
Okay. So I'll give like a minute to think about it.
Could you go back to the exterior angles notes? I just want to. Okay, remote interior angles. Exterior angle. Triangle is equal to the sum of its remote interior angles.
And the remote interior angles in this case would be angle X and angle Y. Okay, so basically for this question, if the two, like if you're gonna think this way, like say if it's true, then you're gonna have to like prove that it is. So assume it's true, then you're gonna have the two exterior angles equals 180. And since the sum of the exterior angles is 360, you're gonna have the last exterior angle be equal to 180. And if you remember the remote interior angles, then you're going to have two interior angles of the triangle add up to 180, which is not possible because the total interior angles should equal 180. So having two angles add up to 180 in a triangle is impossible. Therefore, is not possible for two exterior angles of one triangle to be supplementary.
Wow. I was just thinking it's wrong. I was thinking it was wrong, just because I did not have any reasoning for my answer. All I thought it was just it just looked a little bit dumb. It just doesn't look possible because in my mind I was just like drawing triangles.
Yeah. All right. I think we did this question like a while back, so I think we can skip this one. Okay, so we're gonna do this one. 3 angles in the diagram are marked as right angles. If the angle on the very right equals 27, find the value of the other marked angle that's not 90, which is this angle here, theta. Give 2-3 minutes.
I have a question. When they mean the very right, do they mean angle DBE?
Yeah. Yeah, it's this angle DBE equals 27.
Okay. I think how we can solve this problem is first we can find the length of this first triangle. So 27 degrees plus 90 degrees equals 117 degrees minus 180. So this angle here, angle BDE, this equals 67.
You mean 63?
Oh, sorry, 63, yeah. Yep, 63. 363. Then, because this is a 90-degree angle, we can subtract 90 degrees from 63. So we can say that angle EDA, this angle right here, is 27 degrees. 27 degrees. And this angle here is another right angle because these two angles added up together are 180 degrees. And angle DEB is a 90-degree angle, so the angle DEA has to be a 90-degree angle. So then after that, we can conclude that this is another 63-degree angle. This is another 63-degree angle. And also, this angle is also 190 degrees because of the explanation of angle DEB plus angle DEA. And after that, we can conclude that this is 27 degrees because this is a 90-degree angle, and this is the part cut by a triangle DEA is 63 degrees. So this is 27 degrees. So then this angle here is this angle here is 90 degrees plus 27 minus 180. So this is another 63-degree angle.
Yeah, that's correct. But the question was just asking what this angle theta was equal to. So like,
find the value of the other marked angles.
Yeah,
so
it's just going to be the angle ADE right here, marked theta. That's the name for this symbol, theta. It's used in
parentheses theta.
It's used in trigonometry a lot. Once you go you study more into it, you'll see this symbol a lot more, representing like an angle measure.
So yeah, that's why I didn't understand one thing what you were talking about. A single thing.
But yeah, like you just went and solved all of the angle measures, which they were correct.
So basically, how I did it is just I found out that angle theta is 90 degrees minus EDB, and I think that's called phi. Phi is also 90 degrees minus EDB, so theta and phi are equal. So theta is just 27.
Yeah, that's correct. Okay. So we're gonna move on. So this is just like basic can you remember your congruency theorems? So it should take just an instant read. So just someone go, why are they congruent? Or are they not?
They are congruent.
By which theorem?
Red relevant triangle congruent, and explain why the triangles are congruent. They are not congruent. Explain why.
SSS congruence.
Yeah. Okay,
Literally
so
just say SSS congruence because they're already marked.
Yeah, that's basically what we was asking. It's just SSS congruence. They're congruent.
Because BC equals BC, so that obviously means that they're SSS congruents.
That's correct. Yeah.
Congruent.
Okay, so this is just another. Can you remember what the congruency theorems are? Are they or are they not congruent? And if they are, by why?
Although they look congruent, They may not be. They are not
They may not
guaranteed
be
to be
congruent because we don't have enough information.
Yeah, we don't have enough information.
And also you can't just walk in here and it's like step aside peasants, GF equals GI. There's no mathematical proof that this is true. And you also can't prove the angles are equal.
Congruence is not for congruence. SSA cannot prove congruence.
Yeah, that's correct. So yeah, like they do share an angle side side. If you see FE, EG, and then they share that vertical angle, EGF and HGI, but ASS is not a congruency theorem, so they're not congruent.
It's SSA.
You can't say they are not congruent. You say they like there's not enough information or something. You can't guarantee they're not congruent.
Generally, in these types of questions, you'll just say it's not congruent because, like, if it was to be congruent, then it would probably be marked. So if it's marked like this, it's assumed. It's just assumed that it's not congruent. And I remembered it as ASS because it just was like the easiest. Yeah, it was easy.
That's not appropriate.
It made it easy to remember which one wasn't the congruency theorem.
Yeah, that's not appropriate.
Nope, we gotta keep it PG.
Okay. All right, so here's the next congruency one.
Parallel lines makes this a lot, not simpler, but just a lot, how do I say it?
Okay, SAS congruent. The end.
Yep, exactly. You can just say that JL. You can just say I think it's ASA.
Oh yeah,
it's gonna be. It's gonna be
AS.
It's gonna be ASA.
ASA or AAS.
Because of the parallel lines, JKL, angle JKL equals angle NLM, and it goes to the same thing for the other angle.
You can do AAS or ASA.
And technically, you can also do AAA. If you have like these two are going to be congruent and these two are vertical, so you could either do ASA, AAA, or AAS, but they all work.
AA is similar.
Yeah, they all work.
AA is for similar triangles, right?
Oh, sorry. Yeah, that's very similar. And here's another congruency one.
AAS, the end.
Yeah, it's AAS. Because you have angle B
Yeah, but
and D.
AAS is pronounced the same as that.
It's AAS.
Yeah, it's AAS. As you can see, angle B, and then this vertical angle C, and then this line.
Swamp. Find the isosceles triangle's vertex angle if one base angle equals 6 degrees less than half the vertex angle.
Yeah, you can get a little bit more time for this one.
Okay, that's just mean. Find the isosceles triangle's vertex angle if one base angle equals 6 degrees less than half the vertex angle.
Yeah, you just get an equation and you're done.
Equation. Come on, brain, give me an equation.
I'm not telling you the answers.
I'm not talking to you, I'm talking to my brain.
What?
You know
Okay.
this is
Makes
just
some sense.
This is just supposed to be a joke. No, I'm actually just forming an equation right now, but I'm just trying to make it fun. But it's not funny. Can you tell us the answer now? I don't get it.
Okay, so if you have an isosceles triangle, so you're going to have the vertex angle and you're going to have the two base angles that are equal to each other. So the one vertex angle, give it, just like call it angle x, or like equal to the variable x. And then if you see the base angles is 6 degrees less than half the vertex angle. So the base, so like in terms of x, that would be x over 2, and then you would subtract 6 from that. So you have x over 2 minus 6. So to find the vertex angle, you just want to solve for x. So you're gonna have x plus 2 times x over 2 minus 6, which is the base angles. And that's gonna be equal 180. So that's going to, you multiply that 2 through, you're gonna have x plus x minus 12 equals 180. So you should get 2x equals 192 equals 96, I think. Yeah, x equals 96.
I'm just one. For some reason, I'm just going to say this right now. But why is Adrian just choosing to turn on his video right now?
Because I'm teaching.
I don't know, but I'm just saying, out of all of the times you could have chose to turn on your video, you can do it now.
Well, so I'm teaching today, so I have my video on. Okay, so the next question, just find what x is.
It's pretty.
Okay, I need to annotate this one, and I'm going to talk very fast. This angle equals this angle, which equals this angle. So 5x equals 180, and
this angle equals that angle, which equals those angles, which equals these angles, which equals I think that's all.
So 5x equals 180 degrees.
I think that's all of the.
So 36 degrees. So
Whatever.
36 degrees.
I think that's
x, so x equals 36 degrees. X
Yeah, x equals 30. Okay, so for everyone else, for a more calmer explanation, if you see here, this is an isosceles triangle. So angle C is going to be equal to angle B. And if you have these two parallel lines with like this transversal AB, 2x is going to correspond to angle B here. And since this is a isosceles triangle, angle B is equal to angle C. So you have the interior angles, x plus 2x plus 2x, which is 5x. And then 180 equals 5x. 180 divided by 5 is 36. So, yeah.
Sorry for the very loud explanation.
It's fine.
What the?
Okay, so yeah, this has no numerical values, but find angle A in the diagram.
Okay, so I'm going to annotate on this. Okay, this is 60 degrees and this is 180 degrees. So this angle equals 120 degrees. And because this is an isosceles triangle, this equals 30 degrees and this equals 30 degrees, so A equals 30 degrees.
And that is correct. So yeah, you just use since this is equilateral, it'll be 60.
It's shorter and calmer, so appreciate it.
Yeah, it doesn't get the full message out. It's like, you have to state that like this is an equilateral triangle, so therefore angle B will be equal 60. That's like the reason why it's 60.
It was a little bit obvious. I was just saying it was a little bit obvious because all of the angle sides are marked as equal. So
yeah, but like for some teachers in the future, they'll be like really stingy with what you have to state. Like I'm sure some like my teachers in the past will have you actually have to, like for example, if you took this question, you'd have to state that like since all of these sides are equal, it is an equilateral triangle, and then you can go from there. It's a little annoying, but that's just how some teachers do it. Okay, in triangle PQR, S and T are points on sides PR and QR. Triangles PTS, PTQ, and RTS are all congruent. Find the angle measures of triangle PQR.
There, you got something real. Wait, do you have a picture of the triangle?
I don't think so. Yeah, I don't.
Well, at least you have BTS. It's still.
Okay, so I want to try to tackle this, or you want me to go ahead? All right, let me try drawing. Okay, so start with a triangle. All right, and then this is going to be P. It's hard to see. Okay, this is going to be Q. This is going to be R. So you have a point S on, point S on side PR. Let's call that S.
So.
Yeah. Point T on side QR. So call this point T. And then you have triangle PTS.
PTS, PTS.
PTS. And then triangle P, T, and Q. And RTS.
RTS are all common.
And just ignore how I drew it, but they're all supposed to be congruent.
So, okay, so they're all supposed to be congruent. So it says find the angle measures of triangle PQR.
Yeah. So
couldn't it just be an equilateral triangle? Wouldn't that make it a little bit easier?
I mean, it's.
I'm just saying, if it was
like with this information, I think you would have to try to prove if it's equilateral or not. Okay, so
now we're doing this. Okay, if you don't know, my weakness is proving things.
Okay, my weakness is writing the proof.
That's both. I can't.
You know, like I know how to prove it, except I don't know how to write it out to the teacher.
Just give it a try. Just give it a try.
It's just without a drawing, I'm almost clueless. Without a drawing, I'm almost clueless because the diagram really helps me. Oof, my pillow fell down. I don't have any stress balls, so I'm using a pillow. Don't judge. And I still don't get this problem.
It's a very poor problem, I'd say. So like this solution doesn't actually make too much sense. It says because PTQ is congruent to RTS, angle PQT is equal to angle RST, which makes sense. And it says angle PQT is equal to 90 degrees. that part doesn't make too much sense to me in the solution. And then so since angle QPT, TPS, and SRT are all equal because of the congruencies, QPR is going to be equal to 2 times PRQ. And so you're going to have 180 equals PQR plus QPR plus PQR, which is 90 plus 3 times PRQ. So using that, you can figure out that PRQ is 90, or sorry, PRQ is 30. And so the angles of the triangle is going to be 90, 30, and 60. Solution doesn't really make too much sense, so I don't think it's that good of a problem. All right. Okay, so it's 7:48, so I think it's time. We're gonna take a quick 5-ish minute break. So we'll come back at 53.
AD equals BD and AE equals DE equals EC. Prove that AC equals BE. Okay, just don't worry. I'm just gonna be here solving this problem. So prove that AC equals BE. Wait, I need to get my notes. Okay. So to prove this, we basically need to prove that triangles involving these two lines are congruent. So then we can just prove that AC equals BE. So we can just so yeah, I'm just gonna draw. Yeah, don't mind.
Okay, so it's 7:53. We're gonna resume class. So if anyone wants to tackle this question, go right ahead.
So basically how we're gonna prove how you just prove it is how you prove this is by making sure that triangle ACE and triangle BDE are congruent. And basically how you do that, so these two sides are equal, these two sides are equal, and yeah, these two sides are equal, these two sides are equal. And the last thing we need to prove is that either an angle or angle is equal, because we can't prove that a triangle is equal. And basically this has, wait, no, sorry, I forgot.
Okay.
I forgot the last part.
Okay, you're on the right track. So you have those two sides are equal. So if you see here, angle BDE is supplementary with ADE, right? And since ADE is equal to AED, because triangle ADE is an isosceles triangle, and you can see that
That's how we prove
triangle AEC is supplementary to AED. So using that sort of logic, you can prove that AEC is equal to BDE. So then you'll have an SAS congruency. Therefore, AC is equal to BE. So that's that question. Okay, 10 seconds. What's the area?
Uh, 54.
Isn't the
Actually, yeah,
area just base times height? So is that divided by 2? So isn't it 9 times 6, which is 54?
Yeah. These are really
I
just
did not look at the solutions. It just popped up while I'm explaining this.
Okay, so this should be quick. What's the area?
96.
Correct.
Yep.
All right. What's the area?
Find the area.
So 12.
Yeah, it's
6.
12. It's
Remember
12.
it's area divided by it's this big triangle.
Yeah, you're going to have 4 times 6 divided by 2 being 12.
12.
Okay. Find the perimeter of a square that has an area equal to 75.
√3.
Find the perimeter of a square that has an area equal to 75. There's a lot of perimeters.
20 √3.
It's going to be 20 √3, yeah. So if you have the area, since it's a square, you're going to have one side is equal to square root of 75, which is equal to 5 √3, because you can split it up. You can split up square root 75 into square root 25 times square root 3, and square root 25 is just 5. So you're going to have 5 √3. And since it's a square for the perimeter, you just multiply it by 4, and so you get 20 √3. And that's the perimeter. All right. Find triangle ABC and triangle XYZ's perimeter, given that the area of triangle ABC is 24 and the area of XYZ is 30.
Yeah, you don't have to give the area because
Yeah,
just the
you
Pythagorean
technically
theorem.
don't. Technically, you can just use Pythagorean triples for this one.
Okay, 24
So perimeter is
and 24 and 30.
24, so is it so that's 24. 24 is 30, so that's
24 and 30.
12, 30. ABC's area is 12 and XYZ is 30.
Yeah. Okay, so this is going to be some
Triangle's length is 2 less than 4 times the
variable work.
rectangle's width.
Yeah.
The
So rectangle
rectangle's
length
perimeter
is 2
51
less
times the
than
area.
4 times the rectangle's width, and the rectangle's perimeter is 51. So find the area. Just give you a little bit of time. Okay, so for this question, you have to relate the length to the width. So the length is 2 less than 4 times the rectangle's width. So see, we're gonna do this. So the length L is equal to 4 times the width minus 2. And you're going to have the perimeter as 51. So that's 51 equals 2W plus 2L, which is if you replace 2 times 4W minus 2. And if you just solve that through, you'll get 2W plus 8W minus 4. So that's 10W equals 55. W equals 5.5. And then you would
wait, is that a 1? 1 equals 4W minus 2?
That's an L for length.
Oh, L. Okay.
So then if you plug W back in the length equation, you'll find length equals, I believe, 22. Yeah, 22 minus 2, which is length is going to be 20. So for the area, you're going to have 20 times 5.5, which is going to be 110, I believe. Yeah, 110. Okay. This one's a little annoying to do, so I think I'm going to skip this one because basically for this one, all you do is just break up the figure into like a rectangle and a bunch of right triangles, and then you just calculate the area. It's a little annoying to do in this format, so I think I'll skip this one. Okay, so that's it for these review questions. So I think we're going to start Kahoot with, I think we're going to start doing...
Kahoot equals Yahoo, which equals email.
Wait, I have a question to you. KA equals hoot. What does IT equal to?
Okay, K equals hoot, then IT equals exclamation mark.
Yes.
Yeah.
Wow. Alvin is a genius.
Yeah, I was a genius all my life.
Adrian. Okay.
So here's the game pin.
7117.
Correct.
What's all the doubles for? Oh yeah, and also the triples.
I'm not too sure.
Yay, I am on. The most the most cheesy joke about math, what happens when a plant is in math class? It says it grows square roots, but somebody actually made square roots in real life.
Oh really?
Yeah, so they put a whole
image.
So, okay, I will show you the square root.
Square root real life.
real life.
Plants. Square roots in plants.
Yep.
Oh, yeah, I see. Square roots. I googled it and I actually found square roots.
Told you. Told you. Math is in real life.
It looks so cool. Square roots. 2227117.
I think that's just yes. Creates a gadget scientist, which is gonna actually. What? So the Gonzal's gonna shoot twice now? The Gonzal's a science scientist. So this shoots extra time.
I'm still thinking of a good name.
Why is nobody still here?
Because I'm thinking of a name.
I already thought of a name.
Well, I didn't.
What is that?
How do I know? Yeah, like you've got these functions called fx equals x. Fx is just the same thing as y. If you see a function called fx equals x, it's just the same thing as y equals x.
Okay.
F of x is basically just like the name of a function.
Yeah,
But-
fx is just y. These mathematicians just think that y isn't formal enough and want to look cool, so they replace y with fx when you're in high school.
I mean, there's a more complicated answer, but yeah, sure.
Yeah, sure. You can just think of it as mathematicians think y isn't formal enough and want to feel more and want to be more cool, so they just replace y with fx. Fx equals x is basically the same thing as y equals f and y equals x.
What do you get? What do you get when you add the when
We
you
already know you are anonymous.
wait, I have a question for you guys.
You are already not anonymous because I already know who anonymous is anonymous.
Wait, I have a question for you all. What is the sun minus the moon?
The sun minus the moon? How do I know? The sun minus the moon is
It's a eclipse. It's a eclipse.
Oh yeah.
Okay,
Like
so
Euclid.
we have 11 students in here, but we only have 5 people in the Kahoot. So I'm gonna ask everyone to please join for.
Anonymous, you're not anonymous. Just stop calling yourself anonymous. You're not anonymous. Anonymous.
Can just more than 5 people join? Because seriously, do you really think it's just 5 people every single time?
Yeah, other people don't participate.
And besides, where's Elika? Isn't Elika supposed to be Elika 11?
Elika's calls
Yeah,
her
this is the last
anonymous.
Most of the time it's Elika 11 or
Yeah, but-
anonymous.
Yeah, now
So-
she's anonymous.
So it's not. So in the chat she just said I'm not anonymous this time. So it must.
Yeah,
be
she's lying. She's
How do
definitely
you know she's
anonymous.
lying? How do you know when she's lying?
Who else could it be?
She's in the game. You know
How
I'm
do
in
you
the
know
game.
Wiley's
Because
got
I know his name.
hope Emily. I don't know who is Emily, but at least Emily is not Alika or whatever.
Who knows?
The
It maybe is
2000
Elika.
is Kessler and FX is me, and Alika always participates, so she must be anonymous. There's no other possibility.
I'm so paranoid.
Okay, so I'm going to give like until 8:10 until I start the game, but please everyone join the game because we have a lot more people in the class than people in the game right now.
Come on, can just more people join? It's not like it's gonna be a worldwide broadcast.
Yeah, okay. Thinking of that, I'm actually going to record it. Just kidding.
I'm just seriously saying, why are people so afraid of going on Kahoot? It's not like a worldwide broadcast. You can
Come
just
on. If there was 5th place, then everybody was on the leaderboard, right? Everybody would be on the leaderboard. Everybody would be on the leaderboard. That would be so boring.
I told you, Elika is Hop Emily. A few minutes ago, I said maybe Hop Emily was Elika.
Yeah, but Elika's name isn't Emily.
Good enough.
Okay, enough.
You're dead.
Long live the king.
Long live the king. Oh. Long live.
Guys, I took a picture of the pixels on my computer. I used a magnifier, and I took a close look at the pixels. They look so cool.
I'm just still wondering, why are people not joining? It's still not a worldwide broadcast, so it's not like when you go on there, everybody's just going to be like, "Oh my God, who is that? Who is that?" We just do it to the people who just commonly join. Oh, dang it!
Okay, so it's 8:10, so I'm just gonna start the boot. All right.
What is with all the people not joining?
How do I know?
What formula is used to find the volume of a sphere?
How do I know?
Ouch!
How do I know?
Oh.
How do I know?
Oh.
How do I know?
How do I know? It's
How do I
literally
know
in
if
the
you
chapters, and also, oh yeah, and also I have a big cheat sheet right here. I said cheat sheet.
Okay,
Yay,
yeah,
Gatling PT
4/3 pi
on the
cubed.
podium. Woohoo! Yahoo! What's the volume in cubic inches of the cylinder?
So if you can't see it, it's 8 by 15.
What was the formula for a cylinder?
Well, if you forgot, then you forgot. No points for you.
Eight. Ah.
Okay. So yeah, if you just see here, 8 inches, it's just going to be base times height. And to get the base, it's just pi r squared, which is going to be pi. It's going to be 16 pi times 15, which will get you 240.
Ah, dang it, I'm still on the podium, but I want to get better. What is the volume in cubic meters of the sphere? 12 meters. So it's
winning here. Yes! Yes! He could actually block here, theoretically.
Now stop that.
What?
Stop the shouting or whatever you're watching.
Huh? No! No time to shine wins! Roll 3! Yes!
Yeah, so for this question, you just use that formula, 4/3 pi r cubed, and you just plug in 12 for r, and then you solve out, and you should get this value.
X is in the lead.
What is the volume cubic inches of the cone?
Oh, I see it. I see it. I see it. Wait, what's the height? I can't see what's the height.
The height is 8 inches.
It's
Okay.
the radius is 4, height is 8.
Oh, that's because I'm doing split screen and it's a little small. What? You have to divide by 3, but... Oh, okay, I see, I see. Okay. I'm in. Temporarily unmuted. Unmute. 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 Hi.
Okay, yeah, so for this question, to solve for the volume of a cone, it's base times height divided by 3. So you would do pi r squared for the base. So 16 pi times 8, which is 96. It's not 96. 16 times 8 is 128, and then you put it over 3. So 128 pi over 3 would be the answer.
Pi technically now is proven to be 4. What is the best approximation for the volume of the cylinder by this math? How do you solve it again?
Yeah, all of them are in feet, so like I don't care about the units. Wait, no, that's 22? Oh, great, I'm dead. Wait, no, I'm not dead. Phew. Wait, I am dead. Oh, great. I'm dead, I'm dead, I'm dead. Why am I so dead? I'm dead.
Okay, so
Yeah.
for this question, what you would do is first you would multiply in terms of pi. So you'd have 3 feet as the radius. To get the base, it'd be pi r squared. So you'd have the base as 9 pi times height. So 9 times 22 is 198. So you have 190. So you'll have, you'll have 9, sorry. Yeah, you'll have 9 pi times 22 for the volume, which is 198 pi. And then when you have 198 times pi, it approximates to about 622. And the closest value in this number set is 600. So that would be the best approximation for the volume. So yeah, it's just the formulas just show it's true.
Hi, little sister of Kessler.
What?
I saw your little sister.
Okay, so for this question, it wants to find the volume of all 3 spheres. And if you see, the spheres are all going to be equal in radius since they all touch the top. So you're going to have 18 inches. And if you divide that by 3 to get the diameter for each, you'll have 6. Split that in half. It's 3. Radius is 3 for each. You plug that into the formula of 4/3 pi r cubed to get the volume. So that's what, 12 pi for each, I think. No, that's not 12. Sorry. 27 times 4 over 27. 10. Yeah, I think it's 108 over 3, something like that. Yeah, 108 pi over 3 for each sphere, and then multiply that by the 3 spheres, you get 108 pi cubic inches.
So the height of the cone, so the volume of the cone is base times height divided by 3.
And don't say that answer.
Oh no, I'm just clarifying. I'm just clarifying if I am correct.
Yeah, I
Oh.
don't think
The sound in the background is my brother and his computer. It is not a MacBook. It is just like, you know, those little kid computers.
Okay, so for this question, it's just like working in reverse. So you have the volume as 1440 pi, and the radius is 12. So if you calculate the base, it's going to be 144 pi. So you divide this volume by 144 pi, and wait, no, that's wrong. Actually, you have 144 pi for the base. So you're going to have the volume divided by 144 pi over 3, and then that should get you 30 for the height.
It asks for diameter.
Okay, so this is another question that's like working in reverse. So you could divide 360 pi divided by the height to get the base, which is going to be 36 pi. So if so you're going to have the area of the base, 36 pi equals pi r squared. So r squared is going to equal 36. And the square root of 36 is 6. R equals 6. Diameter is 2 times r, so the diameter is going to be 12.
Two cylindrical soup cans have a volume of 40 cubic inches. Can the surface areas be unequal?
Yeah, I'm basically given the answer now, but of course they can. They can.
Dang it, misclick.
I think you should call it a mistake. The radius of a cone is double and the height is the same. The volume of the new cone is. Okay, I'm just telling you the answer is not the triangle. AKA my favorite color. AKA.
Yeah, this is basically just following a following a formula with like no numerical value for the variable. So if you doubled the radius, you would plug in 2r in the equation for a cone. And since that has that base of 2r squared, that's the only thing that's going to be altered. So that 2r squared will be turned into 4r squared because you square the whole value. And you're going to have the volume be 4 times the original volume because that 4.
Anonymous is okay. Hop Emily. All right.
I didn't get that. Could you try again?
Hi Siri.
Okay.
Hey Siri.
I don't know why, but so for some reason Siri activated. It didn't even say "Hey Siri."
Okay, so it's 8:29.
I said hey Siri.
Hey Siri. Okay,
Okay.
I did.
So it's 8:29. So I think we're going to end class a minute early today. So today was the last class of the geometry. So I want to thank you all for attending class and being attendant. So I think this will be goodbye. So bye everyone. Hope you had a good time learning. Hope you were able to take a lot from the class, and hopefully you can use this knowledge in the future.
Bye.
Okay. Bye everyone.